Hello everyone, I welcome you all to this class. This is mathematics class and today we have this topic to consider: derivative of inverse trigonometric functions. So you have come across some functions like arcsine. Arcsine is same thing as sine inverse. Arctan, which is same thing as tan inverse. Cos inverse, cosec inverse, and so on. So how do we differentiate those functions? So this is what we'll be doing in this class, and I will show you how to do that using examples. So for this question, they asked us for the first question, they said if y is equal to sine inverse of x over a, prove that y prime is equal to 1 over square root of a squared minus x squared. Now y prime is same thing as the derivative of y with respect to x, because the independent variable here is x. So for the second one, they say that if y is equal to sine inverse of 3x minus 1, we should find the y dx, which means find y prime, right? So for the first one, let's prove the first one. Solution. So for 1a, we are proving it. So given y is equal to sine inverse of x over a. Now if you have something like this, sine theta is equal to 1 over 2. How do you find your theta? We normally say theta is equal to sine inverse of what? 1 over 2, right? But what is sine inverse of 1 over 2? Which is what? 30 degrees, right? Sine inverse of 1 over 2 is 30 degrees. Now look at what we have here. If you have theta is equal to sine inverse of something, right? We have theta is equal to sine inverse of 1 over 2. This simply means what? That sine theta is equal to what? 1 over 2. Look at this question. Y, if y is standing for theta here, right, is equal to sine inverse of x over a. Just like we have sine inverse of 1 over 2, right? It means that sine theta, which means sine y, will be equal to what? X over a. As we have it here, sine theta equals 1 over 2. So if you compare this equation, this simply implies that what? That sine y equals to what? X over a. So this implies sine y is equal to what? X over a. And this implies what? If you multiply both sides, by the denominator here is a, multiply both sides by a, you will have that what? That x will be equal to what? A sine y. So I multiplied both sides by a, the denominator. So now the one that is made the subject of the formula is what? X, which means that what? In this equation now we have now that x is what? The dependent variable and y is the independent variable. So in this equation we are saying that x depends on what? Y. So we are going to be performing the derivative of x with respect to what? Y. Because right now y is now the independent variable. You normally differentiate with respect to the independent variable. So now this implies that what? The x dy will be equals to, if you differentiate sine, you get what? Positive cosine. A cosine of y, right? Then, but we are looking for what? We are looking for y prime. Y prime is what? Dy dx, right? We are looking for dy dx. So, but what do we have here? What we have here is dx dy, which is the opposite, right? So how do we return it to dy dx? You take inverse of both sides or reciprocal of both sides. So we take reciprocal of both sides. Reciprocal means 1 over, right? You take reciprocal of this, just do 1 at the left hand side. You do the same, 1 over dx dy. If you do 1 over dx dy, the denominator will come up and the numerator will come down, right? So this simply implies that what? This simply implies dy dx is equals to, do the same thing here. We do 1 over this one, just as we do it 1 over this one, right? Do here 1 over a cosine of y, right? So, but you know that dy dx is same thing as y prime, right? So this simply implies that what? Y prime is equals to 1 over a cos y, right? Okay, but in our proof, this is what they want us to get. Not, they want us to get the answer in this form, not in terms of cosine, right? So but we have an important expression here. They say sine y is what? X over a, right? But we know the relationship between sine and cosine. But from trigonometry, we know that what? Sine squared theta plus cosine squared theta equals 1, right? That's what we know. Then we want to write cosine theta, we want to write cosine y in terms of what? In terms of sine y, because we know that sine y is x over a. And now in our proof has to do with a and x, right? So not in terms of cosine. So we want to write cosine in terms of what? Sine, so that we can replace sine with x over a. Do you get that? So let's use this trigonometric identity. Then making cosine a substitute in the formula, this implies that what? Cosine squared theta will be equals to, move sine to the right hand side, 1 minus sine squared theta. If you move sine squared theta to the right, it changes to negative. So what do you do? Take the square root of both sides. This implies that cosine theta will be equals to square root of 1 minus sine squared theta. If you take the square root of both sides, right? If you take the square root of both sides. So we have, so this implies that what? This simply means that what? Cosine y will be equals to what? Because what we have here is that theta now is y. Cosine y will be equals to square root of what? 1 minus sine squared y. So that's what we have. So this simply implies that what? Y prime is equals to 1 over a square root of 1 minus sine squared y. Right? This is what we got. This is what we got. Can I close this within with a bracket? So this will be equal to what? 1 over a into square root of, but what we have first is 1 minus, what is sine y? Sine y is x over a. We are having sine squared y, which means x over a all squared. So it means x over a all squared, because sine y is x over a. Sine squared y means x over a all squared, which is same thing as what? X squared over a squared. So it's clear, right? So this is what we have. So this simply implies 1 over a into LCM, right? Use knowledge of LCM, square root of our LCM here, this fraction inside. What's our LCM? Our LCM is what? A squared. So we have a squared, right? A squared is our LCM. So we have 1 is same thing as 1 over 1, right? So that 1 divide a squared, we have a squared, multiply by 1, we have a squared, minus a squared divide a squared 1 times multiply by x squared, we have x squared. So with this we have solved the fraction, and this is what we have. So using the property of square root, so square root of this fraction will be square root of the numerator over the square root of the denominator, right? So this will be equals to 1 over a into square root of a squared minus x squared, right? Then over square root of a squared is what? A, right? So what I did is that, this is fraction. So I did the square root of the numerator over square root of divided by what? Square root of denominator. But square root of a squared is the same thing as what? A, right? But we have a outside multiplying this a, so they will get cancelled, right? So what do we have? This implies that our y prime is equals to 1 over square root of a squared minus x squared. So with this we are proving this. We are proving what they asked us to prove. So, but we are going to use this result to solve the second part. So let's continue with the second part. So 1b now. Question 1b. What did they give us to do? They say that if y is equal to sine inverse of 3x minus 1, we should find dy dx, which means find y prime, given y is equals to sine inverse of 3x minus 1. So for us to tackle this one, what we are going to do, we are going to call this 3x minus 1 u. Let's call it another variable u. So for us to perform this differentiation. So, and when we do that, we are going to use this one we have gotten before. It will help us in the differentiating this. So we are going to say let u be equals to 3x minus 1. And this simply implies that y is equals to what? Sine inverse of what? U, right? Because I've called this 3x minus 1 u. So, and we have y is equals to sine inverse of 3x minus 1. If 3x minus 1 is u, then y will be equal to sine inverse of what? U, right? So this is what we have. Now we are going to do what? What we want to use is knowledge of what? Chain rule. Knowledge of chain rule. Knowledge of chain rule. So which says what? You differentiate the inside, right? Then multiply. Use the result to multiply the derivative of this sine inverse, right? So we want to differentiate this inside. That's the one I called u. So du dx will be equal to, if you differentiate the inside, which the one I called u, if you differentiate this, you are going to get what? 3. But if you differentiate negative 1 is a constant, right? Differentiate, you get 0. Then differentiate 3x, you get 3. Then this is what we have. But we know something from the other one, right? But what do we have? But y equals sine inverse of x over a implies what? Implies that y prime is equal to what? 1 over square root of a squared minus x squared. This is what we got there, right? This is what we got there. Though this also implies that d dx of sine inverse of x. Now look at what we are doing here. I use this result we got earlier, right? So this is a well-known result. We are using it to differentiate this. So we have that we are given that y, from what we have earlier, that if y is equal to sine inverse of x over a, that the derivative will be square root of 1 over square root of a squared minus x squared. Now, we what will be the derivative of sine inverse of x? What will be the derivative of sine inverse of x? So this implies, from what we have here, this implies that the derivative of sine inverse of x will be equals to what? Will be equals to 1 over, look at what is given. Sine inverse of x over a is, if you differentiate it, you get 1 over square root of a squared minus x squared, right? Now, what will be the derivative of sine inverse of x? Now, x is the same thing as x over 1, right? So in this case, our a, which is the denominator, is what? Our a is 1. So you put 1 here. So the derivative of sine inverse of x will be 1 over square root of 1 squared, because we're having a squared. 1 squared is the same thing as 1 minus x squared. So this is what we have now, but we want to use this result to get the derivative of sine inverse of u, right? So this implies that the derivative of sine inverse of u with respect to u, right? With respect to u. So if you mimic this thing we got here, just as we have derivative of sine inverse of x, so with this, if you mimic it, so this implies that what? This will be equal to the derivative of sine inverse of u will be equal to 1 over square root of 1 minus u squared, right? If you compare this and this, so this is what we got. But you know from chain rule, right? From chain rule, as I explained earlier, you differentiate the inside, multiply by, you differentiate this outside, right? So that's what I've differentiated the inside, right? I've differentiated the outside. So this is what we have. So now dy dx, from chain rule, dy dx we know is equals to what? dy du multiplying what? Du dx. This is what we know from chain rule. So this will be equals to what? This will be equals to what? What is dy du? dy du is this. We differentiated this function with respect to what? U, right? Because we have here, see, we have here y is equals to sine inverse of u. So dy du, which is this thing, is what we got to be 1 over square root of 1 minus u squared, using this identity, right? So this will be equals to what? Dy du is 1 over square root of 1 minus u squared multiplied by, what is du dx? Du dx we got to be what? 3, right? So this is equals to 3 multiply 1, the denominator will have 3 divided by square root of 1 minus, what is u? U is 3x minus 1, open bracket, 3x minus 1 squared, because we are having a u squared inside this bracket, right? So can we simplify this further? This is 3 over. So can we simplify this further? This will be 3 over square root of 1 minus. If you expand this, what will you get? If you expand 3x minus 1, 3x minus 1 square is 3x minus 1, 3x minus 1, right? If you multiply 3x multiply 3x, we have 9x squared. 3x multiply negative 1 is negative 3x, and negative 1 multiply 3x, we have negative 3x, Negative 1 multiply negative 1, we have positive 1. So in other words, we are going to have 9x squared. So this will be, we have minus outside, right? We are going to have 9x squared. Negative 3x is negative 6x, then plus 1, right? This is what we are going to have. This will be equals to what? 3 over square root of, if you open this bracket with minus, remember I have 1 before, right? If you open this bracket with minus, have minus 9x squared plus 6x minus 1. So 1 and negative 1 will get cancelled, right? You get cancelled. So what do we have left? What you have left is that this is equals to 3 over square root of, but negative 9x squared, negative 9x squared plus 6x is the same thing as 6x minus 9x squared, right? So this is just to simplify further, but this result is also acceptable. This is just to simplify it further. So thank you so much for being part of this class. See you in our upcoming class.